Section 9.1, we're going to talk about solving linear equations. A linear equation tells me that I'm going to have a straight line if I wish to graph it. And it also tells me that my variable term, in this case here is using x as the variable term, has a degree of 1. If it's anything other than 1, then it's not going to be a straight line and it won't be linear. And then they're using B, C, and A as constants. A is attached to x, so that means that's the coefficient on x. Okay. So you may want to pause the video, read this, write it down, whatever you need to do. Reach out to me if you have any questions. Okay, let's start solving. So example 1 says determine whether the given real number is a solution to the given equation by substituting for the variable and checking to see if it results a true or false solution. So just because I can solve x, I get an answer doesn't always mean it's a true solution. So they said, hey, what if x equaled, in this case here, -7, and you plugged it in, does it give me a true solution? Let's check it out. So in the place of x for this equation, I'm going to put -7. And I'm going to see if one side of the equal sign equals the other side. And if it does, then it's a true solution. Then I will say x equals -7 is a true solution. Well, -7 plus 5, that's like saying I have $5, but I spent 7, leaves me with -2. This works out great because -2 is equal to -2. So this is true. Another way we could have done it, we could have took the x plus 5 and said, okay, let's solve for x. That means I got to subtract 5 from both sides. And that gives me x is equal to -7. So yeah, that's true. Of course, in this case here, it's easier just to plug in what's given to you. Let's do C. C says I have absolute value of y. Well, that absolute value tells me whatever I put in y, it's going to come out as positive, right? So it don't matter whatever I put in between these brackets. If it's negative or positive, when it's said and done, I drop the brackets, it's going to become positive. They said, well, see if -3 when plugged in for y gives me a true solution. So let's do it. So I got absolute value of -3 minus 6. We want to see if it equals this other side. Well, I got to rewrite it because I'm going to drop that -3 out of that absolute value signs. Well, that became positive, no longer negative, right? Subtract it to this 6 here, and I get -3. Oh, check. This is true. -3 does equal -3. All right, example 2 just says solve for the variable term. And if you notice, A has just the variable popped up once. There's no like terms on either side of the equal sign to clean up. So let's just go ahead and solve for x. By subtracting that 15, since it's positive, I'm subtracting it from both sides. So now I have x is equal to, I had $8, spent 15, now I have -7. B, I'll let you do B. Let's do C. Before I could distribute, move anything to one side, because if you notice on A, we made sure the x term, the variable term, is by itself, isolated, has a +1 coefficient, then we can state what it is actually equal to. In this case here, I have 11x minus 10x. They're both to the first power, so that means that I can put these two together. It is linear. I have 11x minus 10x, meaning I had $11, spent 10. Now I have 1 times x, which is x, and it's a positive. If it was negative, we'd have to do some work. Plus 4 equals -21. Well, now I need x by itself, so I'm going to subtract the 4 from both sides since it was positive. I get x is equal to -25. And if it asks you to check your work to see if it's a true solution, I can take, let's do A right quick over here. Take the original equation, and plug in what we got here. And let's determine if it's a true solution. We want to see if it, equals this other side. Oh, I wrote 18. Let me scroll up. It's at 15, sorry. So -7 plus 15, meaning I had $15 spent 7. Yep, that gave me 8. So yes, that's a true solution. Let's check C here. Let's make sure that our answer is a true solution. So I got, I'm going to use the combined one here. I haven't moved nothing around or anything, but I want to use that x plus 4 because 11x minus 10x gave me 1x, right? So let's plug it in. I got -25 plus 4. Is that equal to -21? Yeah. Because -25 plus that 4 gave me a -21. So yes, that was a true solution. So check, that's true. That's true. Okay, let's do J. Or H right quick. Let's do H and then we'll do J. H says we have a -5/7 coefficient on A and we need a +1 coefficient. So what I can do is I can multiply by the negative because we know negative times negative is positive, and then multiply by the reciprocal. When I do that, 7 goes into itself once, 5 goes into itself once. So now I got +1 on A. What we do to one side of the equation, though, we must do to the other side. I'm going to put a 1 underneath that 7 there just so I know that I'm multiplying straight across. I look at it and I ask myself, is there a number in the numerator that will reduce with the number in the denominator? In this case, no. I do notice I got negative times negative, so that becomes positive. And now I have 7 times 7 is 49 over 1 times 5 is 5. And that's my answer. So let's do J. J says that I have a Y term here and a Y term here, and my constants are all on the other side. So that worked out great. I got all my variable terms on one side, my constants on the other. However, when I look at it, I notice that I have fractions and I'm subtracting and adding. So in order to subtract and add, you must have common denominators. And I see that in every one of these denominators, I have a 3 and a 5. What if I said 3 times 5? Well, that gives me a number that they both will go into, which is 15. So I'm going to multiply each one of these fractions by 15. And when I do that, what happens? 5 goes in itself once and goes in 15 3 times. So now I have -2 times that 3. And then I'm going to put my y with it. Plus, 3 goes into itself once, goes into 15 5 times. So now I have 4 times 5y, and that's equal to 5 goes into itself once, goes into 15 3 times. So now I have 3 times that -2 minus 3 goes to itself once, goes into 15 5 times. Now I have 2 times 5. So let's multiply. -2 times +3 is -6y. +4 times +5 is 20y. 3 times -2 is -6, and minus 2 times 5 is 10. Now let's put together our like terms. I got on this side here, I have a +20 minus 6 gives me 14y. I have -6 minus 10 gives me -16. Now I want a +1 coefficient on y, so that means I must divide by that 14. And now I got -16 over 14. Of course, we can reduce this, right? We can reduce it by 2. We know that 2 times 8 gives me 16, and I know that 2 times 7 gives me 14. The 2's reduce, and now I'm left with y equals -8/7. And let's do K right quick. K says that we have -3/2 equals 6w. That w has to have a +1 coefficient in order to say what it's equal to. So I need to divide by that 6. I'm going to rewrite it. I got -3/2 divided by 6. And anytime we're dividing fractions, we're going to keep, change, flip. And when I do that, now I get -3/2 times 1/6. I'm going to reduce, and I can. 3 goes in itself once and goes into 6 2 times. So now I have -1 over 2 times 2 is 4. And that's my answer. Okay. A publisher relies on people across the country to submit the recipes to be used in their latest cookbook. If a total of 27 recipes are required or is required for the cookbook and 9 recipes have already been chosen, how many recipes are needed to complete it? So it would make sense to set this all equal to 27 because that was the total. We already received 9 and we need X more. We're not sure how many more we need. We just know it's X more. So let's solve for X by subtracting 9 from both sides. And when I subtract 9 from both sides, I get X is equal to 18. So I need 18 more.